Hi, everyone. Welcome to the Microsoft IoT Deep Dive. I'm excited for us today to deep dive into live video analytics on the edge. So if you are interested in a platform for you to build intelligent video applications that can span from the edge to the cloud, this is your session. So I'm joined here today with Milan. He is a product manager on the video analytics team. Hi, Milan. How's it going?
I'm going great, and I'm truly excited to be here.
Yeah, I'm excited to have you here. Can you explain a little bit of what you do on the team?
Yeah, so I'm a product manager on the video analytics team. I work with a variety of customers, helping them solve problems. And I work with the product team to build these technologies to do so.
Okay, wonderful. Well, thanks, Milan. Milan's going to be walking through, what is live video analytics, how that's being used at IoT Edge. He'll deep dive a little bit about Media Graph, what Media Graph actually is. We'll talk about the different use cases together, and then we're going to close with all the resources that you can go ahead and get started and be able to deploy in your own applications. So if this is your first deep dive that you've been to, this is a live event. So go ahead and ask your questions in chat. We'll be there. I'll be there as a moderator answering all of your questions relating to Azure IoT Edge. And then we'll have folks from the team answering questions about the live video analytics. And if you're viewing on demand, we do have resources at the end on after you watch this video that you can go to get your answers or your questions answered by the team. All right, so maybe let's go ahead and just jump into that intro. Milan, did you want to go over what is video analytics and just kind of overall, what are the goals?
Certainly, and thanks. So, in today's environment, cameras are everywhere. You go to any business location, and these cameras have traditionally been used for security and surveillance. But with all the innovation that has happened in the last few years, it's now possible to analyze these video signals to extract business insights. And what we are doing with live video analytics is providing a platform for developers to be able to build these kinds of capabilities into their existing solutions in a very easy manner. And that's what the product is about. And as Pamela mentioned, live video analytics spans from the edge to the cloud. So what we have is live video analytics on edge, which is in the form of Linux containers for x64 and ARM64 platforms, and also live video analytics in the cloud. And that's available in the form of REST APIs as part of our Azure Media Services product. Um,
Yeah, and Milan, I love that you mentioned you have capabilities for, AMD and ARM, and I can imagine that, this unlocks a wide range of devices. Does this also work with existing CCTVs? Can you deep dive a little bit more into the type of devices that we have support for?
Certainly. So live video analytics on Edge, as a Linux container would work on any x64 device, as I mentioned. So that means devices like Intel NUC and ARM64 devices like Jetson Nano or the Jetson Xavier. They would all work well for this. And yes, it works with existing any camera which supports the RTSP protocol, which is a well-known industry protocol. So our product can easily be integrated in any such environment.
That's great. It's funny you mentioned the Jetson Nano. I was actually building a project with it this week, so it's great to see I can already start playing with the live video analytics. You mentioned Linux containers. What about Windows containers? Is there support there? Going to be support? Could you talk a little bit more about the support when it comes to Windows containers?
So currently, live video analytics is available as a Linux container. You can run Linux containers on Windows. So if you have a Windows-based environment, you can still use our product effectively.
Okay, wonderful. And So just like our other Azure IoT Edge modules as supported by the product team, we have it in the marketplace, which is exciting, and we'll provide a link towards the end on how you can go to the marketplace to go ahead and get this module to test it out in your own application. Okay, well, thanks, Milan, for going through those questions. I've been talking to a lot of developers, coding with a lot of partners and customers who are really interested in deploying video analytics on the edge. Could you talk a little bit about what type of developers will be interested in putting this into their solutions, and what type of scenarios you would that people would use this in?
Certainly. So live video analytics can be used by any solution developer who is looking to add video analytics to their existing IoT solutions. So you could be a developer who is designing solutions for retailers. For example, if you're designing a curbside pickup solution, you can do that. You could be a developer who's focused on building workplace safety kind of solutions for manufacturers, and our product would serve the needs over there also. The key thing to note here is that you don't need to be a video or AI expert. We've abstracted away that complexity and provide you simple APIs you can use to orchestrate the video and AI workflows of your choice.
Yeah, this is great. I did see this need across multiple industries. So this is great that you've highlighted what are some scenarios, but there's a lot more scenarios that would benefit from this that isn't listed on the slide. But this is a great start to get people excited about this. And I also really love that you said you could be a developer where maybe you're not an AI expert and still work with this module. So could you showcase how live video analytics works and kind of that workflow of the overall application?
Yeah, so let's look at this diagram on the slide. So what you have here is a business environment consisting of cameras and some IoT sensors. There is an existing video management system over here, which is typically used for capturing video and providing security and surveillance experiences. Some VMS systems also have some basic analytics capabilities. Now, what you're seeing here is this big light blue box, which is essentially an edge device with the IoT Edge runtime. And it has the live video analytics module, along with some AI and business logic orchestrated on it. And as you can see at a high level, what LVA does is it enables you to capture video from your existing cameras, so you don't need to invest in new cameras. It can also potentially source video from the VMS system, and then perform some analysis on it. And that analysis could be done by AI of your choice, and then publish the results to other services that of your choice. And that could be some business logic, or it could be directly to Azure services in the cloud. So this combined enables you to build business apps which are spanning the edge and the cloud.
One thing about Azure IoT Edge is that we have a wide range of modules that we offer. For example, Azure Stream Analytics. Azure Stream Analytics, if you're not aware, is supported on IoT Edge. We do have a module for that. Azure Stream Analytics is really great at analyzing data in real time. And so I'm curious on how that can integrate with the live video analytics offering.
Yeah, actually, LVA can work very well with Stream Analytics as well. As you can see, the publish box over here, it is publishing time series data associated with the video. And that stream can be fed into Azure Stream Analytics to perform additional analysis, such as you want to do some sort of time window-based counting or averaging. You can do all that and code up the Stream Analytics queries of your choice before that data is forwarded to your app or a cloud service to render it in Power BI or a custom application of your own. So yeah, we have all those integration capabilities.
That's great. And it's, I know you're going to touch on this later, support for some of the cognitive services that you could deploy on the edge. So I'm excited for you to dig into that a little bit later. Could you dig into, now that we've already seen kind of how it works in the full application, a little bit more about uh, live video analytics, deep dive right into that module, what's available, the media graph, and what the media graph is?
Certainly. So, media graph is the core concept at the heart of the product. And what media graph is basically an ability for you to define the video workflow by specifying source, processor, and sync nodes and the connections between them. So as the names indicate, sources enable you to capture video, processors analyze the video and do things on it, and then the syncs can be used to direct the output, which could be video or it could be text data coming out of the video to appropriate services, such as Azure Media Services in the cloud, or it could be IoT Hub or Event Hub or something else. The Media Graph also provides you capabilities to plug in your own custom media processors via an extension capability, and we will be covering those in the following slides. It also enables you to plug in your custom business logic. So it is essentially the flexibility that you get via that concept.
Yeah, this is great. Especially for developers where might be your first time learning about sources, processors, and syncs. This is super helpful to at least know the terminology and understand how it fits into the live video analytics. Could you dig a little bit deeper? Because I would love to learn a little bit more about the capabilities there.
Certainly. So as you can see on this slide, these are the sources, processors, and sinks that are available in LVA. Let me spend a little bit of time talking through these. So there are two kinds of sources. The first one is RTSP. So RTSP is a well-known protocol in the industry, and it enables LVA to capture video from your existing cameras. IoT Hub Message enables you to capture messages from other modules that may be running on the same device or a different device. And that's what enables you to now combine the video with those messaging capabilities in the media graph to achieve your business goals. On the processor side, we have a motion detection processor. So if you have a camera pointed at a site where nothing is happening most of the time, but occasionally somebody shows up, and that's what you're interested in, you can use the motion detection processor for that. The next two processors, which is HTTP and gRPC extension, they provide capabilities to bring your own custom media processors and plug into the media graph. So this enables you to route video frames from LVA to your own processor and then return the results back for further routing. Signal gate is yet another processor which enables you to control the data flow in the media graph based on signals which may be arising from AI inferencing or from an external source. And this is where the connection between the IoT Hub message source and signal gate comes into effect. And then we have three different kinds of syncs. So the first one is an asset sync. So asset is a concept in Azure Media Services, and it is essentially the video presentation concept. So using the asset sync, you can record video to the cloud either continuously or based on events. There is also a file sync that enables you to record video on the edge device itself. And then a IoT Hub message source. So if you are generating events in your module based on AI inferencing, you can use the IoT Hub message sync to route those events to either other modules or to IoT Hub in the cloud. So with a collection of all these things, you can achieve several different kinds of scenarios, which we'll talk about in a moment. So I hope, Pamela, that helps answer the question.
Thanks, Milan. Really appreciate you going through that. There's multiple ways when bringing ML to the edge. One is they use our cog services, and then they make their own custom AI model is another way. So if we're going to talk about cog services a little bit later, what about people who have their AI model, a custom one that they're using? How do they plug into this?
Yeah, so what you're seeing here is an example of a media graph where you are able to bring in your own AI model, package it in a IoT Edge module yourself, and plug it in with media graph. And what this media graph is doing is it's enabling you to run inferencing on the incoming video stream at a frame rate of your choice while recording video continuously. So imagine that if you are trying to build a video playback experience where you want to have a video player and show a timeline of when certain events occur, you can easily do this. And you do not have to worry about either the video workflow or the complexity of routing messages to various services. You get all that from the product itself. Now, this is an example of a very simple scenario. Let's look at how you can extend this concept of media graph to address a more complicated scenario. So in this slide, what you're seeing is a different kind of media graph. And here, you're not trying to record video continuously, but you're trying to record video based on AI events and certain business logic. So let me explain this a little bit. So you have the RTSV source, which is capturing the video. The frame rate filter processor is sampling the frames. Then you are using HTTP extension to route the frames to your AI inference service. And those events are then routed by the IoT Hub message sync to IoT Edge Hub. From there, you can pick those events in your own business logic to process them. So for example, if you're running object detection over here and you just want to look at objects of a certain kind above a certain confidence threshold, you can program that over here and then put a signal back on the hub. From where the media graph can again pick it up and trigger a signal gate. So what the signal gate is doing over here is it's holding the video back in a buffer until the signal arrives. When a signal arrives, it is forwarding that video to media services in the cloud. And the signal gate can be programmed to have logic such as record 1 minute of video whenever the signal shows up and make sure that you start the recording 10 seconds in the past. So all that kind of stuff is possible with just simple JSON configuration. You don't need to worry about setting all this up. That's just a JSON description, and you get going with realizing this kind of a scenario. So these are the two examples of how you can use media graph. There's a lot more combination possible. Pamela, I hope this kind of gives you some idea about what's possible.
This is great. And I think, lots of times in different scenarios, there's a lot of different, AI modules that's going to be coming into play into one application. I think this is amazing to see this one if you're, only have one module. But what if you have AI coming from modules coming from different sources, maybe different partners building these AI models? How do they work together, and just how does that flow look?
Yeah, great question. And yes, we do have those capabilities in the product. And what you're seeing here is two diagrams. The first one is using a single AI module, and the second one is using two of those in sequence. So the benefit is that these could be coming from two different sources and you're just trying to compose them together. Absolutely, you can do that. But it can also help you optimize the utilization of hardware resources. So just to dig in a little bit over here. So as you can see in the first graph, what is happening is you're getting the signal, you're running motion detection. When something interesting happens, you're processing some frames. And you could be using like a YOLO model. Now that's a pretty heavy model. It takes quite some resources. In the second one, what you're seeing is there is tiny YOLO followed by YOLO. And tiny YOLO is much more lighter weight compared to YOLO. And if you put these in sequence, you get overall efficiency in the utilization of resources, which we'll see in a moment in the form of a demo.
All right, thank you, Milan, for going through how to work with these complex scenarios with multiple AI sources. And so I think everyone's excited to just jump into the demo and see how it works in action.
Yep.
In this demo, we will first use this topology where whenever a motion is detected, it will trigger the heavy YOLO model to perform inferencing operations. Here, we have a sample video showing people walking through a staircase. Now let's activate our topology instance against this video sample. As you can see in the debug console, we're getting inference results from the heavy YOLO model along with the confidence value when people are detected. We see that there are about 43 times that the heavy YOLO model was called. Now let's pick up one inferencing result. For illustration purposes only, I have stored the image along with its bounding box in a container. Let's open and see it. As you can see, in this frame, YOLO v3 detected 3 people. Now let's switch to another topology where we trigger a tiny YOLO v3 model whenever a motion is detected. If the tiny YOLO v3 model cannot detect people with a confidence value of more than 0.75, it will trigger the heavy YOLO v3 model. Else, it will skip calling it and share the inference result directly. Let's run the topology now. And we see that the tiny YOLO v3 model returns a result when it's confident, and only when the confidence level is low, it triggers the heavy YOLO model for inferencing. As you can see now, instead of having 43 calls to the heavy YOLO model, it now has called it only about 14 times. Let's pick a situation where tiny YOLO model was confident to return the result, and in the next frame had to call the heavy YOLO for inferencing. Now, what you will see in this image is that only 1 out of the 3 people were identified confidently in this frame, and it did not call the heavy YOLO model. Let's pick up the next frame now, where it actually needed the heavy YOLO model to be called. And now, what you will see is that instead of detecting just 1 person, it actually detected 4 people in the frame.
So you just saw the demo. Now, we saw examples of how you can bring your own AI and plug it into Media Graph. But there is some things which are available pre-built today. For example, in the marketplace today, we have a IoT Edge module available from Intel based on OpenVINO. And that plugs in really well with the Media Graph. And it provides certain pre-built models like person, vehicle, bike, and face detection, and also vehicle classification. If you are familiar with the OpenVINO development concepts, you can also use your own model and plug it into the OpenVINO model server, and that way use it with LVA. The benefit of this is that OpenVINO model server is optimized for Intel CPUs, VPUs, and GPUs, so you get the most optimal performance you can get on Intel hardware.
And I've had a lot of experience with building applications with NVIDIA DeepStream, and we have really great integration with IoT Edge with DeepStream. Do you have any samples? Do you have support for that? Because I know you mentioned that NVIDIA early on in this session.
Yes, we do actually have a sample of using LVA with NVIDIA DeepStream. So all that happens in that case is that you replace the HTTP extension with gRPC extension, and you can use the sample module that we have available in our GitHub repo, and use DeepStream, which is optimized for the NVIDIA GPUs.
Okay, wonderful. Thanks, Milan.
And here is an example of the Cognitive Services Spatial Analysis container, which is actually optimized for the NVIDIA T4 GPUs. So that integrates really well with LVA as well. And there are 4 skills provided today, which is about person count, person crossing line, person crossing polygon, and then measuring the distance between people in the video frame. So these things plug really well, and we do have a demo of that as well.
We have, for cognitive services, we are continuing to add support for Azure IoT Edge. Could you list the other ones that LVA works nicely with?
Yeah, so we LVA works nicely with custom vision and face API both.
Okay.
Um, you can use custom vision to build a custom model and then export it to a container. And the container, of course, exposes a web service endpoint. You just need to take that web service endpoint and configure the HTTP extension in LVA. And that's how you get the pluggability. Uh, the same story applies for Face API as well. So all those cognitive services work well, and we have samples for it. We looked at some of the different capabilities that MediaGraph provides. This slide talks about a few more things. So today we also have an integration of LVA with IoT Central. There is a video analytics template available which enables you to use IoT Central in combination with LVA on an edge device. Which means you can get started with building a video analytics solution without writing a single line of code. And the Edge module that is provided for the connection is open source. So if you want to take that and modify it to meet your custom needs, you can do so. Another feature which we just released is the ability for you to use output selectors across the various nodes in the media graph. What this means is that suppose you have a video camera which is emitting both video and audio, but all you are interested in is routing video through the media graph, you can do so now. So you get that flexibility. We also enhance the disk space management capabilities. So what happens is that when you're dealing with video, you're recording them on your edge device, you can run out of disk space pretty fast. So rather than worrying about building something custom for disk space management, we have inbuilt capabilities where you can simply provide us some configuration, such as limit the amount of video stored by this media graph to so much capacity, and we take care of cleanup internally in the product itself. LVA now also exposes metrics via Prometheus, which is an open source systems monitoring and alerting toolkit. So this provides you capability to consume metrics on your edge device itself versus routing it to the cloud. So these are just a few of the examples of our capabilities, but there's a lot more you can learn about our product. And this slide has pointers to different resources. So we have samples, we have a GitHub repo, we have some videos which show you how to use the product. And if you have questions, you can send us an email at this email alias, and we will respond back to you.
Wonderful. And then if you're getting started with Azure IoT Central, we do have, as Milan mentioned, a template, an application template. So when you're in IoT Central, you can go ahead, go to that build tab, and then you will be able to see video analytics template right there. Click on it to create that application and get started. We do have a trial period too. If you don't have an Azure account or just want to get it started and just test it, that you can go ahead and use. Thank you, Milan, for giving us the overview of the resources available. We'll make sure that those links are in the description below. That way you could go ahead and click on it and start playing with it. And our last resources is really our core developer resources. So we'll go ahead and jump into that slide right now. We have some places where we always recommend developers, if you're an IoT developer, it could be an embedded developer all the way to cloud developer, to check out. One is our Microsoft Learn site. This is where we have hands-on labs. So if you're interested in learning about Azure IoT Edge and how to get started, there is a sandbox experience for you to learn in hands-on labs. Next is watch and learn through our IoT show and our deep dives and our different video series. We're going to continue to do videos about our different products that are coming along in Azure IoT and across Microsoft, focusing on IoT. And then if you have projects or want to share, your scenario, reach out to our IoT tech community. We have a full community there where us and engineering and other folks from the community are sharing their projects, hearing the latest announcements, reading blog posts, submitting blog posts. So check that out. And then if you have technical questions, we also have Microsoft Q&A. Microsoft Q&A is great. Let's say if you have a question about IoT Edge or IoT Hub or anything about building your IoT solution on the technical side, you can go to Microsoft Q&A. Think of it kind of like a Stack Overflow, but on Microsoft. So thank you so much, Milan. I really appreciate you showcasing and coming in and talking about the different workflows. What is live video analytics?
Yeah, and I was glad to be here and talk about the product. Looking forward to hearing back from customers and developers about, how this product is helping them solve their business problems.
Wonderful. And thank you, everyone, for tuning in. And we're excited to have you continue to see our next deep dive, which is going to be deep diving into Azure Digital Twins. So thank you, everyone. And we hope that you have a great day. Bye.
Bye.